Okay, that's a map.
It is a map.
That's RViz. It's a 3D map. Oh, come on. You can actually see the LiDAR scans. Is Dr. Katz out there?
2 out of 3D map.
He'll tell you it's not a LiDAR because it's not time of flight. But you can actually see the scans there. This is a neato bot vac with a Raspberry Pi. I drove around and made this map. I saved the map. I killed the map. I loaded the navigation stack. And I'm going to click on the 2D nav go, point, press, and drag. Mouse up. You see the
Path line.
what do you call the green one? Path planning line. Thank you. And the robot's driving from one end of the room to the other. We have a contest called the Floorbot Challenge, which is 3 phases. Phase 1, build a robot that goes from one end of the room to the other and back. Phase 2 is to find an object in the room, and Phase 3 is to fetch the object. This is part of the HBRC challenge that we do during the months of June, August, and September. So here the robot's lifting up his sleeve. See, it's autonomously navigating. Yes, Steve Dillon. All right, good to see you, buddy. All right. Let's see if, I've got an obstacle here that's less than 4 inches. The LiDAR is planar 2D LiDAR, and it can't see anything below 4 inches. Oh, by the way, this is a Ross, and we have our SV Ross. Thank you, Gloria. SV Ross meetup, the penultimate Wednesdays, and a lot of HBRC's special interest is Ross, so we do a lot of stuff with Ross. I want to do one thing here, and that's I'm going to clear the cost map. See if I can't make this go a little faster here. Oh, now he's doing the whirling dervish. This is like a recovery mode here. Oh no, he's figuring it out. You see the localization there? That's the local cost map. Yeah, and that's the LiDAR scans. That's what your robot uses to navigate. See how much fun we have? Okay. So there's going to go all the way to the other end of the room, one end of the room. I'm going to manually click I'm going to manually click to have it go back to the other side. I've been trying to do this, and I've done it before, programmatically. I've written a package called Floorbot that basically sets waypoints, and the robot can go from one place to another and back again. And so I'll be demonstrating that next one. But the trick, and I refigured it out just earlier today, is that you set the pose, and when you set the pose in the RViz window, those of you who don't use Ross, it's based on Linux, and you'll have several terminal windows open at the same time. But the point is that if I set the pose, it gives me the XY coordinates in the terminal window so that I could then paste into this program and have it go to waypoints in the map programmatically. So here we've gotten to the other side of the room. Oh, and I've got the goal in a place where he can't quite get to that chair, so he's not happy. If I may, I'm going to move it out a little bit here. Okay, nothing up my sleeve. Got new plan, bless you. Got new plan, got Dr. Alan Fetterman, ladies and gentlemen. All right. Excuse me. So glad to have you with us. You were on your nationwide tour there.
I had a lot of stuff going on.
Yeah, a lot of stuff going on. Okay, got a new plan,
GPS signal lost.
Oh, damn it, I've lost my GPS signal. What the hell? Goal reached, we're there, okay. So that's that. Any questions?
I don't think that's all you've lost.
That's true. Any questions? Okay, so I'll just click on 2D nav go, and we'll just have the robot go to the other side. And that's kind of cool, huh? Let's see. All right. Thank you very much.
Okay. Thank you very much, Cam. Yes. Hello.
Is it a segment?
Follow me. Oh, no, classic.
Follow you.
That's awesome. Gotta get robots. Is it on? Gotta get robots that are lighter. I'm getting too old to carry them. Anyway, my name's Bob, and some of you who've been in the club for the last 20 years might have seen this robot. It was initially called Follow Me. And the idea of Follow Me was to be able to carry stuff. And we had a vest. It was all sonar driven. So the bottom part down here was the avoidance system. And then we had two ears here, one's kind of popped in. And then the person wore a vest. And wherever that person went, the robot followed about 2 feet behind. And it worked really well. But, you know, we proved the concept. That was 2005. It's been sitting in the closet for a long time. So I decided, and it had like 5 or 6 PIC 18s in it. And, you know, that's kind of getting old technology. So I thought, well, okay, let's make this maybe into a Robo Magellan. So, still using the sonars. And there was a lot of talk this last week on using sonars for avoidance and mapping. Mapping doesn't work very good, but avoidance can work really well. Before everybody came, I tested it, and he went down the aisle, came down, went in the middle with all the chairs, didn't really hit the chairs, and then turned around, came back out, all on his own. And that's using, essentially, there's 9 sonars in the front, and I've got 2 looking out that direction and that direction. So I'm only using 11 of the 15 sonars that I can use. This board is a board that I designed way back when, and it uses, geez, my light's bright. It uses just the Polaroid driver that drives essentially one sonar at 400 volts. But what we ended up doing is multiplexing that. So I can multiplex up to 16. And so that's what it's using. It's now being driven by one Arduino Duo, and it's doing basically a lot of stuff. One of the things that Wayne had said, I didn't see Wayne tonight, had said one of the things which was important is still having a bumper. You can have as many sonars as you want, but you still got to have a bumper. And a good example of that is, if you look down, the table's legs that come out this way that have the wheels on it, it's right at this angle where the sonars don't see it, but the bumper does. So if this wasn't for a Robo Magellan, I'd end up bringing this bumper down, but obviously I don't want to go through grass and stuff and have the bumper go. It's also got a little display, which is, I'm getting old, I can't see, but I've got bigger ones. But it actually can show, probably nobody can see it, but I can show all the sonars going. So here's the pattern of all the sonars. So, you know, how do you control 16 sonars? And that was a problem that, you know, I was looking at this week, and I just decided to make it kind of simple. And it looks.
Sonars are hearing.
Yes, those are, like I said, it's the Polaroid driver with the square sonars that we get from Senscom. So, and they're at a 15-degree angle. So I basically just broke stuff down to the minimal, 4 zones. A yellow zone, a green zone, yellow zone, blue zone, and red zone. So the robot just works on that information. If it gets down, and I broke up the sonars into 3 looking to the left, 3 looking to the right, and 3 looking forward. And then this guy just looks that way. And that's kind of how it decides how to turn. So I ran around here, worked, I was surprisingly well with all these darn chairs. And that's one of the things that sonars, narrow things that sometimes don't see. With this setup, it kind of saw it pretty good. I was pretty impressed. So later on, I'll run it around. If anybody's interested, you can watch it and see how well it works. Any questions? Nope. Great.
How did it follow people?
Oh, that was, yeah. So we had a vest that had a beacon. It was a 40 kilohertz beacon. And these 2 ears listened to the beacon. And essentially, if you were right in front of the robot, it would see that basically the sound coming back on both of them were about the same. If you moved over here, the sound coming from that one and that one were different. So it did the calculation and said, oh, that one's taking longer than this one. And when I say longer, it's like microseconds, okay? So then the robot would turn and follow. And we end up, when we developed the robot, Ted and I, and Ted's not here, we were going to take it to CES and show it off at CES. So we're carrying it through the casinos and down this long hallway.
What year was this?
Ted Olson?
No,
Ted Larson.
Larson, yeah.
Yeah. Oh, this was probably back in
CES.
2006, something like that. Yeah. And so we're carrying this thing through this casino, and I stopped and I said, Ted, I said, what do we have? He said, robot. I said, what's the robot do? Follow me. I said, so why in the hell is the old guy carrying it? So he goes, oh, good idea. So guess who puts on the vest? Ted. So we put the vest on. It followed him all the way down through the door, through the entrance, all the way to our booth. And there's, if you want to see some video of it, if you do All Logic Follow Me on YouTube, I think you'll see some interesting videos. Any other questions? Yes.
I missed the very beginning. I didn't know if you explained it. When you multiplex the
Mhm.
sensors, do you sort of daisy chain one after another? And so theoretically, could you cut that time in half by picking two zones that wouldn't actually reflect to each other? Or is that not a problem?
Yeah, that's a good question. We had several boards that we did, all with different software on it to look at the sonars. This particular one just sending serial data back,
Okay.
so I can't really do anything.
Okay.
But then we went to SPI and I2C, where we could actually pair stuff up and look at it and say, okay, if I'm going to do wall following on the left, I don't care what's on the right. So I'm not going to look at those anymore. So we could go ahead and do that. And we could start looking at different echoes. And sometimes we threw the first echo away and we'll look at the second, third, and fourth echo to determine all kinds of things, which is really cool. Yeah.
Cool.
Any other question? Yes?
How did you manage to follow distance?
These two guys here, we could go ahead and calculate the distance, the time it took to get from the beacon back to the robot. So we also looked at that, and we used that as the time distance for how far to follow along, and it was about 2 feet. One of the simplest things, I think I forgot to mention, when we were developing the software, we were sitting down, and again, Skip Inskeep had written a lot of the software at the time. Really good guy. We're sitting and saying, well, what happens if the robot comes up to something, or a person? What are we going to do? And then I said, well, that's a good question. Well, we only have like 12 hours. So I said, look, if we're in a big crowd, what do we normally do? What we normally do is somebody steps in front of us, we just stop for a second. When it clears, we walk. He said, great idea, let's do that with the robot. We had it at 4 or 5 years at CES, it never ran into anybody. And it worked really well.
Nice.
Anyway, great, thank you.
It's funny, we always think of technology developing at a rapid pace, but this robot that was made 15 years ago is still quite relevant today.
So I'm kind of interested in playing with like making robots sense something and in various ways. So this one started as kind of a wheelbase. It was like acrylic and like these cheap motors. And what I wanted to do is to do some kind of, navigation. So, but I don't want to do that with a LiDAR. So I have like 2 USB cameras on a 3D printed mount. This is not the end design. It should be like much wider. But yeah. So I want to do kind of a stereo vision and like a depth map, and eventually kind of end up with a point cloud, so that you can do some kind of SLAM with that. Right now, I'm in the process of like kind of transitioning to everything to ROS. And one thing with these cheap motors is that it's kind of hard to do precise movement because they don't have any encoders, what's not. But they came with encoder discs, so I bought like optical encoders, and then I mean I have a Raspberry Pi to drive that, but it's kind of hard to do precise readings from encoders with Raspberry Pi because I mean it's not a kind of a real-time system. So I had to install some kind of Arduino. But yeah, I was thinking about Arduino Nano, but Arduino Nano doesn't have enough pins that can do real-time interrupts. So I bought Pro Micro, which has like I think 5 of them. I need 4. But the bummer is that I later decided to move motor control to Arduino so that like they are kind of in a tight loop running on Arduino, and that kind of consumed 2 interrupt pins because I need to do I2C to control motors. And then eventually I figured out that I don't need like this external interrupts. I can go on with pin change interrupts, which you can use on almost any pin. Yeah, so right now I'm kind of in the process of like making ROS to Arduino bridge and tweaking PID controllers, PID controllers for motors. Yeah, and right after that I'm gonna go with stereo vision.
Are you familiar with the raw cereal package?
I'm aware of it.
So it's like super simple.
Well,
I've had really good luck with it.
so I've seen a couple of different types of packages for this serial integration, and one is like you just talk serial, and the other is you have Arduino library that actually kind of mimics as a ROS node. So I probably will go with that one. Okay.
If you want, I'll be happy to give you the code that I wrote. It's called Spunk. It's a serial communication that has a node on a ROS system.
Mhm.
So you could send really fast packets, and then the ROS node will rebroadcast across the ROS network.
Yeah,
If you want.
that would be great.
Yeah, it's really.
Yeah, raw cereal actually does that. It's actually really.
This is
really
this only takes like 100 bytes of RAM in your processor on your robot, so
It's super easy.
it's super easy. Super easy, super fast, and doesn't take any resources.
Okay.
Okay, thanks very much.
Thank you.